Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a problem on the electrostatic energy stored in a charged capacitor. The question is as follows. Two identical capacitors C1 and C2, each of capacitance C, having free space between their plates, are connected to a DC source of V volts and a switch S as shown in the figure. Initially, the switch is closed. Now, the switch is opened and the space between the plates of both the capacitors are filled with a dielectric medium of dielectric constant 3. Find the ratio of the electrostatic energy stored in the combination before and after the introduction of the dielectric. Before proceeding to solve the problem, let us recall the related concepts. The capacitance of a capacitor having free space between its plates is given by C is equal to epsilon 0 A by D, where epsilon 0 is the absolute permittivity of free space, A is the common surface area of the plates, and D is the separation between the plates. When the space between its plates is filled with a dielectric medium of dielectric constant K, its capacitance becomes C dash is equal to epsilon 0 Ka by D, which implies that C dash is equal to Kc. Since K is always greater than 1, we have C dash is greater than C. When a capacitor of capacitance C is connected to a DC source of V volts, then the charge stored in it is Q is equal to Cv, and the electrostatic energy stored in it is U is equal to half Cv square. When the space between the plates of the capacitor is filled with a dielectric medium of dielectric constant K, then two cases arise. Case 1. When the capacitor is not disconnected from source before the dielectric is introduced. The situation is shown in the figure. The capacitance changes to C dash is equal to Kc. Since it is connected to the source, V remains unchanged. Therefore, charge stored in it will be Q dash is equal to C dash V, which is equal to Kcv is equal to Kq. And the electrostatic energy stored in it will be U dash is equal to half C dash V square is equal to half Kcv square, which is equal to Ku. Case 2. When the capacitor is disconnected from source before the dielectric is introduced. The situation is shown in the figure. In this case also, the capacitance becomes C dash is equal to Kc. Since the capacitor is disconnected, the charge stored in it remains unchanged. Therefore, V changes to V dash is equal to Q by C dash, which is equal to Q by Kc, which is equal to V by K. And the electrostatic energy stored in it will be U dash is equal to half C dash V dash square, which is equal to half Kc into V by K whole square, which is equal to 1 by K into half Cv square, which is equal to U by K. Now we are in a position to solve the problem in the question using these concepts. Initially, the switch is closed. Therefore, voltage across each capacitor is equal to V, which implies that energy stored in each capacitor is equal to half Cv square. Therefore, total energy stored in the combination is U is equal to U1 plus U2 is equal to half Cv square plus half Cv square is equal to Cv square. Finally, the switch is opened and then the dielectric is introduced between the plates of both the capacitors. From the figure, it is clear that capacitor C1 is disconnected from source before the dielectric is introduced. Therefore, energy stored in C1 will be U1 dash is equal to 1 by K into half Cv square, and capacitor C2 is not disconnected from source. Therefore, energy stored in C2 will be U2 dash is equal to K into half Cv square, which implies that the total energy stored in the combination will be U dash is equal to U1 dash plus U2 dash is equal to half CV square into 1 by K plus K, which is equal to CV square into 1 plus K square by 2K. Hence, the required ratio is U by U dash is equal to CV square by CV square into 1 plus K square by 2K, which is equal to 2K by 1 plus K square. It is given in the question that K is equal to 3. Therefore, we have U by U dash is equal to 2 into 3 by 1 plus 9, which is equal to 3 by 5. This is our answer to the question.